In this video, we're going to talk about how to solve quadratic equations by completing the square. So completing the square helps us transform quadratics into perfect square trinomials. Remember that we use this technique to transform quadratics from standard form to vertex form, but we can actually also use it to solve quadratic equations. Remember, as always, we're going to start off with our quadratic set equal to 0. Then we're going to move the value of c to the opposite side of the equation. So in this case, the c was a minus 7, so I added 7 to both sides. And then we'll group the ax squared and bx terms. If there's an a value that's not equal to 1, we're going to divide both of these terms by a and factor it out. If a is equal to 1, you can just skip this step. So what we do now is we need to complete the square. So we're going to take the value of b that we have now and then divide it by 2 and square it and add it inside the group. Then to the other side of the equation, to balance everything out, we're going to add the value of a times that b over 2 squared. So if a is 1, that's just going to be b over 2 squared. So now what we do is we've turned this left side into a perfect square trinomial. This is actually equal to x plus 3 squared, and then on the right side we have 7 plus 9, which is 16. This kind of equation, remember we talked about solving in when we did the video on solving by square roots. And so we use all of those steps to go ahead and solve this equation, which gives us the two solutions are x equals 1 and x equals negative 7. So remember, use the process we discussed when solving by square roots to solve the equation after completing the square. So what we did there was, remember, we isolated the square term, right? That's the first thing we did. And when you have the square term by itself on one side of the equation, you can go ahead and take the square root of both sides. Remember, since the square root is one that you add in, you have to do the plus or minus signs in front. So we get x minus 2 equals plus or minus 4. And we can separate this into two equations. We have x minus 2 equals 4 and x minus 2 equals negative 4. When we solve these two equations for the values of x, we get x equals 6 and we get x equals negative 2. So those are our two solutions. So remember, quadratic equations can have one real solution, two real solutions, or no real solutions. And remember, we could see this from the graph, but we'll also see this show up whenever we're working on solving using completing the square. So here's how we solve by completing the square. Remember, first we're going to move c, and then we'll factor a out from the group ax squared plus bx. Then we'll do the completing the square process, and then rewrite what we have inside the parentheses. Then we'll work on solving by square roots. We'll isolate the square, then take the square root of both sides, and then remember to include the plus or minus square root. Then we'll solve for the values of x. So let's solve this equation now by completing the square. So my very first step is going to be to move that value of c. So here c is a plus 24, so I'm going to subtract 24 from both sides. So when I subtract 24 from both sides, that's going to give me x squared minus 10x equals negative 24. So in this next step, I'm going to put that x squared minus 10x together. Since a is 1, I don't need to worry about step 2 where I have to factor a out. So I'm just going to leave some room for myself to complete the square. And so what I'm going to do now is look at this value of b, okay, which in this case is negative 10, divide that by 2, and then square it. So that's basically saying do negative 5 squared, and that's equal to 25. Okay, so now over here I'm going to add 25, which means to balance this out, I need to add 25 on the right side also. So what I've done here on the left side is turn this into a perfect square trinomial. This is equal to x minus, and we have b over 2, which remember 10 over 2 is 5. So this is x minus 5 squared. That's equal to negative 24 plus 25, which is 1. Now we can solve this equation using the process we used when we're solving by square roots. I can take the square root of both sides. Remember, I have a plus or minus square root here. So that's going to be x minus 5 equals plus or minus, well, the square root of 1 is 1. Okay, so I can break this apart into two equations. So I have x minus 5 equals 1. X minus 5 equals negative 1. So now I need to go ahead and solve by adding 5 to both sides. So when I add 5 to both sides, I get x equals 6, which is one of my solutions. And then over here, I'm going to add 5 to both sides. And that gives me my other solution, which is x equals 4. Okay, so we have two real solutions to this quadratic equation. So now you can go ahead and pause the video and try doing this example on your own. So here what we did, remember, we started off by moving that minus 21. Always move C first. So we have x squared plus 4x equals 21, and then we need to add 4 to both sides to complete the square. When we do that, this will become x plus 2 squared, and we have that's equal to 25. Then we take the square root of both sides, which gives us x plus 2 equals plus or minus 5. And then we can separate this into two equations, which gives us two solutions, x equals 3 and x equals negative 7. So now let's try this example. So we're going to solve by completing the square. So the first step will always be to move away that value of c. So in this case, I can do that by adding 4 to both sides. So that gives me 2x squared plus 8x equals 4. Well, here, notice that I have an a that's not equal to 1. So what I'm going to do is I'm going to group these terms together, but I'm also going to factor out that a. Okay? So that means that I'm going to factor out 2, and so both of these terms are going to get divided by 2. And so I'm going to leave my right side alone. So that's going to give me 2 times 2x squared over 2 is going to be x squared. And then plus 8x over 2 is going to be 4x. And then I'm going to leave myself some room, and that's equal to 4. Okay, so now I can complete the square. So what I'm going to do is I'm going to take this value of b, which is 4, and I'm going to divide by 2, and then I'm going to square that. Okay, so 4 divided by 2 is 2. 2 squared is equal to 4. Okay, so I'm going to add 4 in on the inside here, but be careful here. I didn't just add a 4, right? Technically, I added a 4 times 2. So when I add on the other side to balance this out, I'm going to be adding a 2 times 4. Okay, because remember, to save the property of equality, we need to add the exact same thing on both sides of our equation. So we're going to rewrite this now as 2 times, well, this is a perfect square trinomial. So it's going to be x plus 2 squared, and that equals 4 plus 2 times 4. 2 times 4 is 8. 4 plus 8 is 12. Okay, so now I'm going to solve this using square roots. Well, remember, to solve by square roots, we need to first isolate the square term. The square term's not isolated because it has a 2 in front of it, so I'm going to start off by dividing both sides by 2. So that is going to give me x plus 2 squared equals 6. Well, now that I have that, I can solve by taking the square root of both sides, right? Remember the plus or minus. So that is going to give me x plus 2 equals plus or minus the square root of 6. So now to solve for x, I'm going to go ahead and subtract 2 from both sides. So when I subtract 2 from both sides, we're going to get x equals negative 2 plus or minus the square root of 6. Okay, and so that gives us the two solutions to the quadratic equation. Now let's try this example. So this is not already in standard form because it's not set equal to 0. So what I'm going to do is I'm just going to move all my constants so that they're together. So I'm going to subtract 5 from both sides. And when I do that, I get x squared minus 6x equals 23 minus 5, which is 18. Okay, so now I'm going to put together my x squared minus 6x and leave some room to complete the square. So I'm going to take that value of b, which is negative 6, divided by 2, and then square it. So negative 6 divided by 2 is negative 3, so we have negative 3 squared, which is equal to 9. So I'm going to add 9 on the inside, which means I need to add 9 over here. So I'm going to rewrite this as a perfect square trinomial, right? Because it's x squared minus 6x plus 9, so that's going to become x minus 3 squared. And that's equal to 18 plus 9, which is 27. Now I can solve by taking the square root of both sides. Okay, so remember over here I have plus or minus. So that's going to give me x minus 3 equals plus or minus the square root of 27. Anytime you are working with a radical, you want to make sure and simplify it if possible. So the square root of 27 can be made better because it is divisible by 9, right? So we have the square root of 9 times the square root of 3. So we have x minus 3 equals plus or minus the square root of 9 is 3, and we have 3 square root of 3. Now to solve, we can go ahead and add 3 to both sides. So when we add 3 to both sides, we get x equals 3 plus or minus 3 square root of 3. Okay, and those are our solutions. So now you can go ahead and pause the video and try doing this example on your own. So here we start off by moving the 16 so that we have x squared plus 8x equals 4. We then complete the square by adding 16 to both sides. When we add 16 to both sides, this gives us x plus 4 squared equals 20. Then we take the square root of both sides, so we have x plus 4 equals plus or minus the square root of 20. The square root of 20 can be made better by factoring out a square root of 4. So we have x plus 4 equals plus or minus 2 square root of 5. Then we can subtract 4 from both sides, which gives us x equals negative 4 plus or minus 2 square root of 5. So now let's try this example. Let's solve this problem by completing the square. So this is in standard form, so I'm going to start off by subtracting 25 from both sides. So when I subtract 25 from both sides, I get x squared minus 8x equals negative 25. Okay, so I'm going to go ahead and group these two terms. So I have x squared minus 8x, and that's equal to negative 25, and I'm going to work on completing the square. So I'm going to take that value of b, so negative 8 divided by 2, and then square it. So that's going to give me negative 8 divided by 2, which is negative 4 squared, and negative 4 squared is equal to 16. So I'm going to add 16 to both sides, and when I do that, I get x squared minus 8x plus 16. Well, that can turn into x minus 4 squared. Okay, and that is equal to negative 25 plus 16, which is negative 9. So now I can solve by taking the square root of both sides. So I take the square root of both sides, and remember here I have a plus or minus, and so I have x minus 4 equals plus or minus the square root of negative 9. Okay, so that square root of a negative number tells us that we're going to have complex solutions to this expression. So now we can go ahead and make that square root better, right? So we have x minus 4 equals plus or minus the square root of 9 times the square root of negative 1. So that's going to be x minus 4 equals, well, the square root of 9 is 3, so we just have 3, and then the square root of negative 1 is going to be I. So now I can solve by adding 4 to both sides. And when I add 4 to both sides, I get x equals 4 plus or minus 3i. Okay, and so those are the solutions to this equation. So let's go ahead and solve this equation now by completing the square. So this is not in standard form, but I'm going to put all my constants together on the right side. So I'm going to do that by subtracting 80 from both sides. So we get x squared plus 4x, and that is equal to 4 minus 80, which is negative 76. So now I'm going to go ahead and complete the square by doing 4 divided by 2 and then squaring it. So 4 divided by 2 is 2, and we have 2 squared, which is equal to 4. So now we can add 4 to both sides, and so this is going to become a perfect square trinomial, so I can rewrite that as x plus 2 squared, and that's equal to negative 76 plus 4, which is negative 72. Now I can solve by taking the square root of both sides, and when I take the square root of both sides, I get x plus 2 equals plus or minus the square root of negative 72. So I can rewrite this as x plus 2 equals plus or minus the square root of 72 times the square root of negative 1. So the square root of 72, I want to think about if I can make that better. So that's going to give me x plus 2 equals plus or minus the square root of 72 can turn into the square root of 36 times the square root of 2. And remember, the square root of negative 1 is just I. So we have x plus 2 equals plus or minus the square root of 36 is 6. We're going to bring that I in front, and then we have the square root of 2. Now I can solve this by subtracting 2 from both sides. And when I subtract 2 from both sides, that's going to give me x equals negative 2 plus or minus 6i times the square root of 2. Okay, and so those are our solutions to this quadratic equation. So now you can go ahead and pause the video and try doing this example on your own. So here we're going to go ahead and start off by moving that 40 to the other side of the equation. So that gives us x squared minus 6x equals negative 21. Then we can complete the square by adding 9 to both sides. So that gives us x minus 3 squared equals negative 12. Then we take the square root of both sides, and then we work on making that square root better. So we get x minus 3 equals plus or minus 2i times the square root of 3. Then we go ahead and add 3 to both sides, which gives us x equals 3 plus or minus 2i times the square root of 3. So remember that completing the square can be used to solve quadratic equations. After completing the square, use the steps we used when solving by square roots to solve for x.